I'm going to do this in English because 我说的中文说的不太好，所以对不起。And thank you to the translators. I'm going to try to do humor in here, and I know how hard humor is to translate, so feel free to just insert a random joke so that they laugh and I look good on video. Sounds good? Somebody got that? That's good. All right. So, we've had a lot of technical information today, and I could give you a lot more, but I think that a little bit of philosophy is probably useful. So, fenestration is an interesting word, right? In English, it's a beautiful sounding word, and it means hole in the wall. And of course, in Chinese, you're very efficient, and you just call it a hole in the wall, right? Well, in the US, if I say, hey, I want to go to a hole in the wall conference, that doesn't sound so good. And I would say, no, I mean, there are lots of holes in the wall. And they say, what? China has a great wall. What happened? There's lots of holes in it? What? That's a joke. Not so funny. All right, I tried. All right, so when I first started in this industry 23 odd years ago, we actually ran an advertisement that said, no one ever called a holy wall a saint. And I never thought that I would end up spending the next 2 decades really trying to understand what these holes are, how they work, where they're efficient, where they're deficient, and what we can do about it. The reality is that, at least in the US, and I'll speak from the US perspective, the gross lack of understanding about moisture, water, bulk water, vapor drive, led to massive failures in our buildings. Anything from the 80s onwards until about 2005 was hugely problematic. The green building movement changed that. Building science came to the forefront. We started to really investigate that. And we've seen the product of that in the last 10 years as our buildings have evolved dramatically. Testing, the research facilities here in China as well, all the work that's being done around the world to change how our buildings perform, to increase our understanding. And that's great. That's wonderful. But the reality is that the majority of failures still begin with those holes in the wall, those fenestrations. Those are things that we need to do something about. So, we have condensation, we have moisture. Moisture does damage, right? This is how our buildings fall apart. We all know that the best buildings we design, we go out 5 years later and we can see the effects of moisture, and they all start from the same place. So, what are we going to do about it? Well, new construction is easy, right? New construction is a vision. New construction says, hey, I've got this idea. I've got a clean slate. I'm going to put together a team of experts. I'm going to draw a beautiful set of plans. I'm going to build it, and it's going to be perfect. I have a team of quality assurance individuals. I have an architect. I've got project managers, and I've got the best details on the planet. Now, I'm looking at this from the perspective of the remodeling industry. And the remodeling industry gets to see what happens a few years after the building is built. We deal with failures. We deal with the things that didn't go right, that didn't go as planned. We are the ones who get to address projects that were left half finished, or ideas for future expansion that weren't completed. And you'd think that in new construction, despite all of those wonderful plans, you wouldn't see things like this, and yet we still encounter things like this. It's hard to imagine somebody built that, put that toilet in place and thought, yeah, sure, why not, this will work. So, we make things like this, beautiful. This is what remodelers get to do after we fix what the builders have done. We have an entire industry, a remodeling industry, that is huge, and it is built largely upon the mistakes that the builders make. Right? It's a massive industry. But we'd be even better if we could stop making those mistakes. So how do we understand the mistakes? And I'm going to be super depressing here for the first few minutes and go through all of the things that are wrong with our openings. There are 5 or 6 primary categories. Now what's important to understand is that some of these things can change and some of them cannot. So we have unit types, right? And we've seen some great presentations here today. We've got pultruded frames, those are awesome. We've got wood frames, we've got steel frames. We have a lot of frame types that we can work with. We have a lot of different wall types. Curtain wall is very popular these days, but it's not everything. We still have a lot of solid masonry, we have concrete, we have hollow masonry, we have wood frame, right? So we have multiple wall assembly types. Then we have the cladding types. Then we place those things in different climates. We orient them differently on site. And then we have a variety of installation methods for each one of those assemblies and each one of those wall types, none of which are consistent. We can go to every manufacturer and we will find a different set of instructions for each one of these things, none of which take into account orientation or climate. And we have a series of labels and performance metrics that, with apologies to all the industries represented here, use their influence to skew to make their products look good. They don't give us good or accurate data about the actual performance of the window in situ. And so we end up with repeated failures. Or we end up with architects, designers who don't really understand the product that they're specifying for the opening that's going. We have wood frames, we have wood clad frames. All of these frame types are fine. There's nothing wrong, there's nothing inherently wrong with any one of these frame types. They all work just fine sometimes. When they're installed properly in the right climate, in the right location, they work great, all of them. This isn't about which one is right and which one is wrong. It's about understanding the pros and cons of each unit type and making sure that you're applying it in the appropriate location. Go back. HVAC. We are not talking about HVAC in this conference, but the building is a system, and there's a relationship between window type and HVAC design. Right? If I have a window that I'm going to put in a high-performance wall with insulation on the exterior of the building, which is what we want, and I have the window installed in the outermost layer, which is great, especially for waterproofing, I now have limited airflow across the interior film of the glass. This is going to result in increased risk for condensation when my relative humidity spikes, when temperature outside and inside are going through wild shifts, right? We all know this, and yet we don't address it. We have a variety of wall types. We have insulation in the wall, we have insulation outside of the wall, we have vented assemblies, we have unvented assemblies, we have vented assemblies that connect to unvented assemblies and the other way around. We have a mixture of wall types and roof types that exist within single building's construction, but no variation in terms of how we deal with any of the fenestrations, whether it's in flashing detail or the unit that's prescribed for the opening. Climate. China has pretty much every climate, pretty sure, right? You have everything from hot, humid in the south to cold in the north to what I like to call Harbin cold, which is super, super, super cold. It's like Minnesota cold. And yet, we use the same method of testing regardless. So I have this very funny cartoon here, right? And everyone's being asked to take the same test. Climb the tree. So that it's fair, we're all going to take the same test, climb the tree, and yet we know that some of these creatures are going to fail when it comes to that. They might be great at lots of things, but in this particular test that we've designed, they're not going to do as well. So we have tests that are designed to make certain products look better than others. We know that we do it in insulation, we know that we do it with wall types, and we know that we do it with windows. So perhaps what we need are different tests for different situations, for different products. Maybe they'll give us more accurate results and we can design better buildings. Then we have installation instructions. We have installation instructions that call for literally every combination of materials, fastening methods, and sealants that you can imagine. We have seal all 4 sides of the window, we have seal 3 sides, and we have seal no sides. We have weather-resistant barriers, our WRBs, that come in a variety of materials, and they call for dog flaps, straight flaps, fold inside all the way and wrap to the interior, fold inside 3/4 of the way and staple. They call for weaving layers of WRB together. Some of these require an origami master to figure out how exactly to put them together in the field. guarantee you that none of our field technicians are that good. We don't pay them to be that good either. And it's great that we have all of these detailed instructions, and yet we still come across buildings that just don't even have a weather-resistant barrier. So it's great that they flashed the side and the bottom of the window to the OSB, but what's happening at the top of the window? There's literally no control there. There's no drainage plan on the system. The other guy is installing the window to the surface of the cladding. That's going to work well. Right? Again, that's sarcasm. That's American humor. It's the best we've got. Here's one. No corner flashings, reversed head flashing, and peeling tapes. Everything done wrong. And this is a photograph on somebody's website where they're proud of their installation. They're showing off their work. Got another guy who, someone in the field realized that he'd forgotten to address his building paper, so his solution was tear it loose and we'll fold it back down there. That's not going to fail, is it? We have installation instructions that vary from manufacturer to manufacturer. We have low expansion foam, 1/2 inch from the front flange. We have low expansion foam, no location listed. And we even have window manufacturers that say, shove some fiberglass in there with a stick. I kid you not, there's an installation diagram that shows a hand pushing fiberglass into an opening with a stick. We have manufacturers that can't even agree on where their product should go. This guy on your left is installing low expansion foam to the outside of the window. I don't know what that's supposed to be. It's not in any installation instructions I've ever seen. The other guy, who's dressed for cold weather on the inside of the building, is installing foam to the backside of the window frame instead of a 1/2 inch from the flange. So the guys who are making the product that's supposed to make the window work don't even understand where it's supposed to go. Doesn't make for a very good photo if I can't see the foam, does it? Flashing materials. We've made so many advancements when it comes to flashing materials. The liquid applied, fluid applied membranes are amazing. The tapes, amazing. Right? We've got some tapes that can do just about anything. Huber's got their super sticky, ultimate flex, super stretch tape that's super thin. It's amazing stuff. And all those tapes are great. But when you walk out on a job site and you see this, does it matter how good the tape is if I'm going to drive cap nails through it and ignore my tape requirements and squirt foam into my joints? This is the reality of the field. I got the most complicated corner flashing tape assembly that I've ever seen in the lower left hand. I have window labels with information that is largely useless. I have 3 data points to choose from. Performance, U value, that's useful. Solar heat gain coefficient, that's useful. Visible light transmission, nobody really understands what it means. And if you're lucky, you might get an air tightness rating, and it will either be something that says A1, 2, or 3, or it will be a number. There's no scale provided. It tells you nothing about what the number means. Nobody really understands it. I have seen almost no windows come out with a CR listing, your condensation resistance. Possibly the most important thing that we should be doing on our window units today, given that we're moving towards high-performance buildings. And it's missing. We're missing the scale. So without a scale, we can't understand anything, right? If I say something's big, and you say, well, how big? And I say, big like a piece of cheese, big. And in your mind, you're thinking big like a skyscraper, big. Big is a useless term unless it's in a scale. So it's messy, it's confusing, it's conflicted, instructions suck, and it kind of makes you want to give up, right? Anybody want to give up out there? No, you guys are hardcore. So, we understand the challenges. What do the solutions look like? Let's start with standardization. Standardization is something that we desperately need in this industry. Without it, we will never get past the stumbling blocks that have been in front of us for the last 20, 30, 40 years. They will just get worse. We need to agree on what those standards are going to look like, and they need to have real value. We need to come up with a way to understand the trade-offs between characteristics. If I'm giving up a little bit of visible light transmission in exchange for a lower solar heat gain coefficient, what does that mean for my building performance? And does it have an impact on my condensation resistance? And is it valuable? Is it more valuable to chase after a window that has a U value of 0.28 or 0.26 and give up a CR factor, or should I lower my U value, allow it to be a little bit less efficient, but be more condensation resistant? Understanding the trade-offs between units in location based on frame type, orientation, and climate is absolutely critical for changing the way that we specify and install windows. We need to talk about frame performance, and we need to talk about its relationship to HVAC requirements. If I need to wash all of my window units with air in order to keep it from condensing, then that needs to be part of the spec. It should be a part of the window manufacturer's process for ensuring that their window survives and is successful. And likewise, if the window unit is durable enough and is resilient enough that it doesn't need additional HVAC, it should be noted as well. We can improve the efficiency in the buildings if we don't have to wash all of our windows with heat. Anybody out there in HVAC design? Probably not. But HVAC on the inside of the buildings, not on the window side, is more efficient than on the window side. We put it on the window side to keep our windows from condensing. If we produce better windows that are sealed better, that are more condensation resistant, then we can move our HVAC to the interior and waste less energy. It's a simple maneuver. It's actually an old one. It's the way that we used to build in the early 1900s. Then we had single pane windows that froze over with ice, which that didn't work as well. We need wall location guidelines and performance requirements. We need to be very specific when it comes to attachment methodology. We have a number of new wall types on the market that window manufacturers have not addressed when it comes to attachment. We have insulated wall panels, where the OSB is on the outside of the insulation, and they're great wall systems. But can I hang your unit off of a half inch of OSB or not? What type of fastener do I need? What do I need in the seismic zone? All of that needs to be addressed, and it should be addressed from the position of the window manufacturer. So window manufacturers looking beyond their units to the actual wall type on which they're being installed is the next step of standardization. And installation details. The industry needs to come together and come up with one installation detail that is universal for all climates, or climate-specific installation details, and be uniform about it. And that's something that is well within our capabilities to come up with and enforce. Installation instructions. It would be wonderful if we could move towards a uniform installation instruction and remove this myriad of conflicting ideas about how windows should be installed. We need better labels with complete data. We need labels with relevant data. And we need explanation of the measurements in the units and the context of each of those measurements. That's the information that will change how the unit is specified. It will change where the unit is installed, and it will change the success rate of the unit, and ultimately the wall. There is a direct line in performance failures between roof design and bulk water management and window and door failures. If I place a window within 3 feet of a roof plane in a climate that sees between 200 and 400 inches of snow per year, that window will be in direct contact with moisture for 3 to 6 months of the year. If the window manufacturers don't explicitly say, my window unit is not to be installed within 12 inches of a roof plane, of a low slope roof plane, it will be installed within 12 inches of a low slope. Because the building industry continues to do it, and the window will fail. If your window can't withstand constant water pouring on it from a roof plane that is ejecting all of its bulk water right at your window unit and right at your frame, it's going to fail, right? So either you design units that can be installed in those locations, or you expressly prohibit those units from being installed in those locations. We see so many buildings where architects or non-architecture designers place windows in locations that are not appropriate for openings. And failures that could be avoided if the manufacturers had simply said, like the siding manufacturers, like the cladding manufacturers, my product is not intended for contact with moisture. You must maintain a 12-inch barrier. You must maintain a 2-foot gap. If there's additional flashing guidelines that need to come with the window units, then that's great. Provide them. If you can come up with a specific flashing detail that will allow your window unit to be placed in a location where it's going to see standing snow, standing water, massive amounts of bulk water, then provide that detail so that we can use it in the field. Architects are great people. They have great ideas, they have great vision. We've seen some incredible structures built all over the world. China has probably led the world in terms of building amazing structures that no one ever dreamed could be built. So our architects are awesome. But they seldom get involved in the repair of their buildings. They're seldom involved in the remodeling of their structures. Buildings get remodeled, buildings get altered. Homes get remodeled, and homes get altered. But the architects are absent once the project leaves their desk. Now remodelers like information, they like lots of information. But the industry doesn't treat them that way. There are almost no remodeling companies in the United States that receive attention from any of the product reps at the level that they serve as architects. Remodelers generally know very little about the window units or the wall types that they are altering and changing. And that's a problem. Because they're the ones who actually like to think about things. They tend to be very creative. They tend to be problem solvers. They're constantly fixing people's mistakes. It would be a huge benefit if the same attention that was given to architects was given to the remodeling community. But more importantly than either of those things is communication with the people who do the work. The boots on the ground and the dirty gloves. And this is not an exciting thing to share with you guys. And nobody wants I think generally nobody wants to talk about it because they're not classy. They don't have a lot of money. They're not going to pay us a lot of fees. But the reality is that we entrust those people to do the work that we draw. We know that we can draw a good set of drawings, and we know that we can produce a good set of details. But when we go out in the field, all those pictures that I shared with you, those are actual installations. There was an architect or a designer involved with that project at some point. Somebody detailed out how to install those windows. But it doesn't make it to the people who do the work. So, possibly most critical in this process of, I would say, fixing our fenestration problem is going to be not with these guys, as awesome and as great and as wonderful as they are, but it's going to be with these guys. They're dirty, they got tattoos, their language isn't so clean, but they're the ones who fix people's mistakes. They're the ones who, when they see a bad detail that comes on somebody's drawing, if they have the knowledge and they understand how the system's supposed to work, can make the change in the field that should be there. If they understand what we're trying to achieve when we talk about flashings, or when we talk about bulk water management, when we talk about vapor resistance, if they understand it, actually understand the system, then when they're putting together, they will have the eye to see the things that are missing. If we put everybody in a kind of a myopic, this is your role is simply to put in a nail. But don't think about what's in the wall behind it. They're going to make mistakes and they won't know about it. They won't even realize that they're making a mistake because they're not connected to the rest of the system. It's a philosophical change more than anything. All the standards in the world, the best, finest, most wonderful standards won't have the kind of impact that we need, until we change the way that we think about communicating those details to the people who do the work. Fenestrations are holes in our walls. We put lots and lots and lots of holes in our walls. But we are building things for people to live in. So fenestrations, while they're the source of so many of our problems, they're also at the same time the most important thing about the buildings that we build. They are the way that we and our families look out and see the world, and they're the things that protect us from it at the same time. So, understanding that this is our biggest challenge, but understanding that it's our most valuable opportunity is absolutely critical. This is literally just an opportunity for us to make our buildings better, to make our homes better, to make them safer, more resilient, and more durable. And so, I want to thank you for your time, and I'd be happy to take any questions that you have.